going to do our third and final problem. We're going to cross two heterozygous tall pea plants. While it might not look like there's enough information to figure out what our parents would be, if you will remember what we have learned so far about genetics vocabulary, you will find that there is. Remember that a heterozygous individual will always exhibit the dominant phenotype. You're being given that dominant phenotype. So we're going to use T's to represent our two parent pea plants. Since they're heterozygous, we have to know that means we would have one capital and one lowercase letter. Heterozygous by heterozygous. It said cross two, so both of the parents must be the same. Now we're going to set up our Punnett square just like we've been setting it up. That was a little crooked, that'll be okay. Remember where your parents go on your cross? They're always going to be located on the side and on the top. Since these two are the same, we truly don't even have to worry about which goes where, and we've learned already that it doesn't make any difference the positioning of the parents. Let's go to our first cross. When we cross these two big T's, the offspring will be homozygous dominant. When we cross the big T and the little t, our offspring will be heterozygous. We cross this little t to big T, and we're going to want to keep that big T in front. Still heterozygous. Finally, we have two small t's, which is homozygous recessive. Then we need to evaluate our cross for our genotypic ratio. We want to be sure that we count all the different genotypes. If you will notice, we have one that's homozygous dominant, we have two that are heterozygous, and we have one that is homozygous recessive. This will always be the outcome of a heterozygous by heterozygous monohybrid cross. You will always get a genotypic ratio of 1 to 2 to 1. Always. Let's figure out how to write that down so it makes sense to everyone who looks at it. Again, one of our individuals will be big T, big T. Two will be heterozygous, big T, little t. The final one will be homozygous recessive, a 1 to 2 to 1 ratio. As you move through this and look for the genotypes, go back to your problem and remember, tall is the dominant phenotype. Remember also that we have learned the presence of any dominant allele means that that offspring will show the dominant phenotype. So for our phenotypic ratio, we have one that is homozygous dominant. We have two that are heterozygous. Therefore, these three individuals will be tall. This one and these two. Our recessive phenotype, we have one, which has no dominant allele. We're going to assume that that one, its phenotype would be short, so we'll say one will be short. Another way to look at this one that is very often written, it's written as a percent. That would be 75% tall, and 25% short. This concludes our review of the three major types of genetic problems involving monohybrid crosses.